Hey, Thomas LaRock here, aka SQL Rockstar. Today, I'm going to talk to you about the top 5 common problems with SQL Server. But first, shout out to my sponsors, Bacon and Back Scratchers. That's right. If you need bacon or you need your back scratch because you're kind of all alone in the world, you don't have a spouse or a partner to do it for you, you head over to Bacon Back Scratchers Unlimited. You tell them that SQL Rockstar sent you. Okay, so today, I'm going to be talking about the top 5 common problems with SQL Server. So I'm talking indexes. I'm talking poor design decisions. I'm talking ORMs. I'm talking bad, stinky code. And I'm talking about using default configurations. So if you like what you see here today, this is important. I need you to hit that like button. I need you to hit that subscribe button, right? I'm working up to 10 subscribers. It's going to be big with my kids. Thank you. Indexes. They're the #1 cause for performance problems inside SQL Server. Now, that doesn't mean SQL Server can't do indexes very well. SQL Server does indexes great. This is a user issue. This is people creating indexes improperly. This is people not maintaining their indexes, right? Outdated statistics, or you have a missing index. Maybe sometimes, right, you run a query and you didn't have the correct index on there, and so SQL Server is going to tell you you have a missing index. You could have, I said, wrong indexes. Hey, you could have too many indexes. You could have, I said, outdated statistics, or you could just not be doing your index maintenance. There's so many aspects, so many layers to the index onion here, right? You are responsible for maintaining these indexes, for reviewing these indexes, and making sure that they're operating efficiently. So the truth is, a lot of these index issues go away with just a little bit of maintenance and preventative maintenance, but that can't be the case all the time. You want your end users to be happy. So what you're going to need is a way to go in and evaluate if the indexes are causing performance issues or not. But that index that you change in order to fix that one query, that one index could be used by a dozen other queries. So you could be making things better for one person and worse for 12 others. So you've really got to have a view of understanding what's at that table level and say, all right, show me those indexes, show me the queries. If I make this one change, what's the true impact of that change? And that's what we're going to look at. So I'm at the home screen for Database Performance Analyzer, good old DPA. And we're going to focus our efforts right now on this guy, this dashboard, this red exclamation point, critical tuning advisor issues detected. Remember, we're talking about indexes being the leading cause for performance issue problems. And with DPA, you are one click away from being able to see that those issues with indexes and queries inside the database. In this particular case, on the right-hand side, you see those red exclamation points again. Those are 3 tables that have been highlighted for you right here saying, hey, you've got issues with indexes and queries. These are the tables involved. So you could look at this right now and be like, that orders table, that's probably an important one for this system. So it's going to help you focus your efforts in order to fix the things that need fixing now. We're going to look at line item. All right, so I come over here, so I'm 2 clicks now, and I've got all this information, a wealth of information. From here, I could look at the text itself, I could look at the plan details. Here's an index recommendation. It says you should put an index on the L_order key column. Look at this, 27 other SQLs. If I click, look at all of these that could benefit from this index. This is a wealth of information. Now, this is truly, you're getting to understand the impact that you would have if you make a change to an index. On the left, look at the inefficient SQLs on this particular table, right? Of course, if I click, it can keep coming down. Now it says more and more information. Now it says included or index columns, no included columns. You're getting a lot of details about the queries hitting the table, the indexes involved. This is what I was saying before, is that you don't want to spend time tuning a query thinking, oh, let me just fix this one index. This query is great. What about those other queries that might be using in those indexes? What about the 72 other queries hitting this particular table? What's going to happen to those queries, right? Performance is going to go up or down. You might make the world great for one of your end users and miserable for 72 others. But with DPA, you're getting this information at a level that I don't think anybody else is able to offer right now. That's called the Table Tuning Advisor, where we highlight the table, we show you the queries, we bubble up that information about index recommendations, all to help you help your users have a positive experience with that system. Okay, now we jump to poor design decisions. I'm not going to say bad, I'm just going to say poor. We all make choices in life. Some are good, some are poor. So poor design decisions, right? Everybody agrees. Great database performance starts with great database design. But we see databases all the time that have things that are not great design. We're talking nested views. We're talking no data archiving whatsoever. Billions of rows when only a few thousand are ever used. And you can have a relational database with no primary keys or foreign keys defined. So what's the point? Why would you have a relational database without defining a primary key or a reference a foreign key at all? You know what? If you have no keys, you might as well take a bunch of Excel spreadsheets, tie it together with PowerShell, deploy it to a bunch of cluster nodes, flash drives, terabytes of RAM, and call it Power NoSQL. You're welcome. So it's difficult to make changes to a system. I get that. You deploy something, you built it, it's been around for 20 years, and you can't make a change at this point, so you've just got to make the best of what you can with what you have at that moment. But you know, that's going to lead to a lot of performance issues for your end users. So let me show you what I'm talking about. All right, so we're back at that Table Tuning Advisor screen, and here's what I'm going to show you why. Remember, we're talking about poor design decisions, and these could have been decisions that were made or not made, you know, when the system was built. So inside of DPA, where would you get the information? Where might you get that, say, that smell test? And you'd look and say, I'm not sure that this database has been designed properly. So the information is right here in the Table Tuning Advisor, because if I scroll down, we're going to get more information about the table itself. So we have the current table information here. I can get an idea about existing indexes. I can see the existing columns. But look at this. Look, what did we say? You have a relational database, but you don't have a primary key? Well, that doesn't seem right. Maybe it is. It could be, but chances are it's not. And this foreign key is not even indexed. That could be a problem as well. Could be. Doesn't necessarily have to be. But we've bubbled up that information for you to look at. And now you can go back to somebody, hopefully it's not yourself, and say, why did we make these decisions? Why did we design this table in this particular manner? Is there a reason? Was there a performance benefit for us leaving off of a primary key or not indexing this foreign key itself? And by the way, here's another one, wide index. This has been highlighted, right? The index, the size threshold defined in your advanced options. Again, bubbling this up, overlapping indexes, poor design, right? Right here, 4 of the 5 tuning best practices not fulfilled. And we bring it front and center for you to understand. You've got a foreign key not indexed, overlapping indexes, wide index, table does not have a primary key. If you want to learn more, there's a little hyperlink at the bottom, bring you to another page so you can understand more about the implications. Now, these things by themselves doesn't necessarily mean that it's a problem. It doesn't. It's just highlighting what could be a poor design decision. You're not really going to get this level of detail and knowledge transfer out of Management Studio, right? It's just not available for you in the native tools with SQL Server. That's the one of the true value adds that DPA brings is we have a lot of knowledge baked into that product for decades of experience across all these platforms. And we're here putting it front and center so you may not have 20 years experience, but you don't need it. All you have to do is be able to read this, comprehend it, and then understand what actions you need to take next. So all those poor design decisions made all those years ago result in bad code. What's bad code? Well, it depends on what you mean by bad code. The bad is a subjective word, right? For some people, a bad code would be you got too many cursors running there, or it could be that where clause. Maybe a where clause is missing, or it could also be over-reliance on user-defined functions because some dev thinks that T-SQL should function just like C++. But it doesn't. It doesn't. So Bad code on top of bad design is going to lead to a lot of issues, a lot of concurrency issues. I'm talking locking, I'm talking blocking, I'm talking deadlocking, right? So Jim in accounting is going to be running that report, and you're not going to be able to do anything because it's really hard for two people to use a database at the same time. So, hey, the combination of bad code and bad design is going to lead to lots of issues for you. I want to show you what I'm talking about. Now, remember, what did bad code? What was an example of bad code? What does it lead to? We said concurrency. So where does DPA show concurrency? Well, it's right here. What I've done is I've connected to an Azure SQL database, and this is the home screen. This is your 30-day rolling window, and we're going to scroll down to the bottom, and you're going to see we have these tabs. Advisors, so some query advisors that you might want to look at, resource SQL text, and right here, blocking. So if I, from that home screen, that one click over to this particular blocking tab, and now I get an idea of the queries that are having issues and being blocked. Now I hover over that, it gives me information, the wait time as the root blocker, the impact on all block sessions. All right, so so this one query was running and blocking more than one other query. So that's why this was waiting for 25 minutes, but because the other number of other queries are running, they actually end up waiting even more, 35 minutes, and that is an aggregate total. The total impact time for the day, 1 hour and 52 minutes of queries simply waiting for each other. That's just concurrency. It's likely bad code, probably a result of poor design decisions. If I click on it again, it'll bring me to this other screen, and now I get that view for that particular day where I can see. It looks like, oh, this makes sense, between 7 a.m. and 6 p.m. That's when the most of the blocking is happening. Okay, what about this other tab? I said locking, blocking. What about the deadlocks? Look at this. Now I get information, the deadlocks that are happening as well. A deadlock is caused by application code. The engine doesn't just get tired one day and things start deadlocking. The only thing that causes deadlock is application code, most likely on top of bad or poor design. And now I can click here and I can get information about this particular deadlock. I can see the victims. I can see that this is an update happening. These are all killed. Deadlock. This is a survivor. These are the deadlocked resources. I get a wealth of information to try to figure out what was really happening and how can I go about fixing it. Where are the objects involved? Chances are I need to think about this at the table level, right? Your deadlocks could be caused by something maybe with a handful of indexes. This is all great information for you to have. The other thing I want to show you why we're here. If I go back to that main screen, this is another little great feature though, anomaly detection. So right in here, we were expecting a certain amount of wait time, and it ended up being a little bit more. We're using actual math here. This is machine learning that's embedded inside DPA that's tracking all the weights over time, and then it builds a prediction, and then it scores itself and sees how well it does. This is what's going to help us understand, say, hey, maybe we're getting a flood of requests. Maybe there's a flood of queries coming in, and maybe that's a result of something that's called an ORM, Object Relational Mapping, and that's what we're going to talk about next. So now we're going to jump to ORMs, or Object Relational Mapping. We call those code-first generators. Now, this is the result of poor design decisions that lead to bad code that leads to some little manager, pointy-haired boss that says, hey, you know what? I'll just get a tool that writes the code for us. That way, it'll be great. No, it's not. You know, ORMs, they can be great when they're used properly. Unfortunately, they're rarely used properly. So, matter of fact, it becomes such an issue. ORMs are almost uniquely causing these problems that it's easy to identify who they are. And it'd be like, instead of cleaning up a crime scene, an ORM is leaving extra fingerprints, hair, and blood because they want you to know that they were in that room. So ORMs end up causing lots of problems with the way the queries are written, the way they're structured. The idea is that you can move this code, and it doesn't matter what data store you have, because you're creating a mapping between the data and the objects inside of the data, any database, right? So you could port this code everywhere. When you have an ORM and it looks kind of like the SQL language, then you're using that ORM wrong. Now, maybe that's just me, but I see these issues arise all the time, mostly in the bloated plan cache. And so, matter of fact, SQL Server created a feature called ad hoc queries, right? So you had this little checkbox where you could say optimize for ad hoc queries, and that would simply try to reduce the amount of plan cache bloating inside of SQL Server. It doesn't fix the problem, right? The problem is still the use of ORMs and the heavy generation of these queries. But you can find lots of blogs on the interwebs about ORMs. I just want to tell you, they are really causing issues more often than not when it comes to your SQL Server. Now we're going to jump to default configurations. This is the last. This is number 5, numero cinco on the list today. So default configurations. Are you a generation nexter? Have you ever installed SQL Server by clicking next, 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 finish? Yes? Congratulations. You now have an installation of SQL Server running in your environment with all default configurations. And these default configurations, they can impact your performance quite a bit. And are you on a virtual server, right? Are you on a VM? Chances are the VM admin also created a server with default configurations. And the server, the backend, there's probably default configurations being made by your server admins as well. So there's a lot of opportunity for performance tuning when it comes to just the decisions around configurations. We're talking things like your max degree of parallelism, your cost threshold for parallelism, your tempDB configurations, transaction log placement, sizing, default file growth, all examples of options for you to understand more about as you're installing SQL Server. And here's the other thing, though. These things can change over time. And right now, SQL Server, there's no way for you to know if these configurations have drifted over time. You can't say, show me what the configs look like a week ago, a month ago, a year ago, until now. Because SolarWinds has found a way to make it easy for you to track these changes over time. And that's what we're going to look at next. So SolarWinds has this product, and it's called Server Configuration Monitor. And that's what we're looking at right here. I'm at the summary page, and I'm going to drill into this particular server, PMSQL. This brings me to that node for that, and check it out. This is a SQL Server database server. And look, all this, we've recognized it. We've applied the SQL Server Essentials pack. These are all configuration options. We give you an idea of the query that we're using to pull this information back. And look at this, I'm focused on the database backup one. You know, you might want to check and make sure that your backups are going to the same location. There's a default backup drive. You wouldn't want somebody to come in and suddenly change that backup drive on you, right? Maybe you do. I don't know. I don't think so. Here's a common one for me that I always had trouble with was link servers. Somebody going in and either creating one, deleting one, or just making changes to the link server. We can capture all of this configuration information. We put it into a file, and then we pull at regular intervals. And then if there's ever a change, we can show you the diff between those two files. So for example, if I come here, it says today at 7:45. If I click, it brings me to that particular change, and it's going to show me what has changed. I can see right here, it went from is cleanly shut down from true to false. I get all this information. I can see who's done what. This is information you are not going to get out of the box from SQL Server itself, right? This is what the value you're going to get by using Server Configuration Monitor. So let me come back to PM SQL. I want you to see all of the essentials that are here. Server configuration, security, registry entries, all this stuff that you would have to have a mix of T-SQL and maybe some PowerShell to get some of this stuff. No, we're going to track it all for you. We're going to be able to put it together. So now, and you're going to use PerfStack with server configuration so that you could track a performance issue and have it related to a configuration change inside of SQL Server. That's gold. Oh, yeah, that's the spot. You got to get one of these things. They are magic. Shout out to the sponsor, Back Scratchers, and don't forget bacon. I love you both. I mean it. So this list I went through today, these top 5 common problems for SQL Server. So we're talking indexes, we're talking poor design decisions, bad code, ORMs, default configurations. Those 5, not a scientific list. No science involved whatsoever. It's just my 20 years experience working with SQL Server. And I want you to think of those five, think of them as buckets, right? There's just a bucket. When you're trying to do your performance tuning troubleshooting, think about which one of these buckets is it most likely fitting into. All right, that's going to help you reduce that mean time to resolution and get it smaller and smaller and smaller, right? So look, I want to thank you for watching. I want you to realize that if you follow these tips here today, you are going to save your boss's bacon, right? Rockstar out.